start with our lesson. I just want to ask a few questions. Misa, what is a current?
It's the rate of flow of a charge inside a conductor.
That's correct. And what is resistance?
The measure of opposition to the flow of current in an electrical circuit, which results in energy convection.
Okay. And Ohm's law?
It states that the current flowing through a conductor is directly proportional to the potential difference applied across its ends.
All right. And what is the formula of Ohm's law? The Ohm's law formula that defines the relationship between current, resistance, and voltage.
I think it's ohms is equals to V divided by current.
That's incorrect. Ohm's law states that the current or the flow of charge,
Yes, sir.
no, it says the potential difference, right,
Yes, sir.
is directly proportional to the current. So V is directly proportional to I, but I is inversely proportional to resistance. So I equals V over R. I equals V over R. So, but I'm glad that you understand most of the concepts. All right. Where did we end last week? It was 2.2.3. Okay, so what is the formula of calculating the resistance of resistors in parallel?
It's R1, it's RT is equals to R1 plus 2.
R1 plus 2.
Yes, sir.
Not R1 plus 1. It's actually 1 over RT is equals to 1 over R1 plus 1 over R2. You agree?
Yes, sir.
Then plus, if there's another resistor, then it will, if there's resistor 3, what do we add?
Plus 1 over R3.
That's perfect. Okay, now how do we deal with resistors in series? How do we calculate the total resistance of resistors in series? If we have R1 and R2 and R3, how do we calculate those? The total.
I think it's going to be V over R1 plus V over R2 plus V over R3.
No. But what you're actually saying is right, but that was the formula we used to derive the resistance in parallel. So resistance in series is given by RT equals R1 plus R2. If there's another resistor in series, it will be plus R3. And last week I have said that if you have a circuit, a complex circuit, what is the first step you must do if you have a complex circuit with a number with a number of resistors, some in parallel and some in series. What is the first step of resolving that circuit? What is it that you must get rid of?
Okay.
There's something you must get rid of. What is it? You must get rid of parallel resistance. You must nullify all the parallel resistance so that you can easily solve your circuit.
Yes, sir.
Okay, so let's go straight to the questions. Okay, we did 2.2.3. So you remember what we did last week was that I resolved the parallel connection of 23 ohms and 12 ohms into one equivalent resistance. Now, how do we find the equivalent resistance? Which formula do we use? Come on.
Okay, it was 1 over RT is equals to 1 over R1 plus R2 plus 1 over R2.
Yes, that's perfect. Parallel connection, 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 if there is resistor number 3. So that's what we did. Then after that, we find the equivalent resistance, which turned out to be 7.5. You remember?
Yes, sir.
Then from there, we have a circuit that is in series. Do you see that?
Yes, sir.
Then if you have a series circuit, how do you find what is the total resistance of resistors in series?
Then we use the formula RT is equals to R1 plus R2. If there's a third resistance, then we add the plus R3.
Perfect. Perfect. The first thing first, you resolve the parallel connections. Second, and then you find the equivalent resistance or R parallel. You can call whatever. Then once you are done with all the parallel branches, you will have a simplified circuit in series. Then you just add your resistance. So that's what you're going to be doing throughout in electricity. So we ended up in 2.2.3, where they said calculate the total resistance of the circuit, which we got. Then 2.2.4, calculate the potential difference between the 3 ohm resistor. Do you have a clue?
No, sir.
Okay, so first of all, you know that your 3 ohms, where is it? I'm trying to get this to the screen, sorry. You know that your 3 ohms is in series with your 7.9 ohms equivalent or effective resistance. Do you agree?
Yes, sir.
Okay. The thing is, in order for you to find the potential difference, What is the formula, or what is the Ohm's law formula?
Its current is equals to voltage over resistance.
Okay. So let me connect the pad quickly. So when you're solving circuits, you must know that the main aim of solving circuits is to simplify them. That means at the end of solving your circuits, you need to find the total of everything, the total that is flowing throughout, or the total voltage of the entire circuit, or the total resistance. Okay, in our case, 2.2.4, you said Ohm's law is I equals
Voltage over resistance.
voltage over resistance. I said last week that I, or the current, is the flow of charges throughout the circuit. So we need to calculate the total flow of electrons in the circuit. So in order for us to solve, to solve the potential difference, we need to have the current. Now, how do we find the current, Kumis? Do we have the total potential difference?
Yes, I think so.
It's how much?
10.9 ohms.
10.9 ohms.
Yes, sir.
Is that the potential difference? It is not. It is the total resistance. The total potential difference is the potential difference that is supplied by the battery, because the battery is supplying the entire circuit. So we are trying to find the totals, or the overall current, using the potential difference across the battery. Do you agree?
Yes, sir.
And the R total?
It's 10.9 ohms.
10.9. Remember, this is the total resistance of the entire circuit. And this is the total potential difference, or the total voltage in the circuit. And it will give us the total what? The total flow.
Yes,
so the total flow will be 26 divided by 10.6. It will be
10.
you got 2.39. I think you agree. Did you get
Yes,
that?
sir. Yes, sir.
Okay, that's I total. That's the total current of the entire circuit.
Yes, sir.
And then the question said, what is the voltage across 3 ohms? What we know is that the total current that we have will flow in your 3 ohm resistor. Do you agree?
Yes, sir.
Because if you're dealing with a series circuit, if you go back to your notes, you will see that the current is the same throughout. I think we're in the same page. Okay, so V at 3 ohms, it will be what?
3 ohm.
It will be?
So are we going to multiply the voltage with the ohms?
Yeah, electricity is all about Ohm's law. Ohm's law throughout. Ohm's law and the principle of adding resistors. That's it. It will be?
Isn't it 168, sir?
It will be?
168. I don't know the unit.
Yeah, but I want the formula first. Voltage equals Ohm's law.
So it's voltage is equals to current multiplied by resistor.
That's it. That's it. Now, how do we substitute? Okay, what will be our current? What is our current?
Oh, it's 26 volts, sir.
Our current is?
26.
No, remember that is potential difference, and potential difference is measured in volts, and those are voltage. Now we're talking about current. Current is measured in amperes.
Yes, sir.
You agree? Because I see you're a bit confused on that one, but it's fine. 2.39 times what is the resistance?
And 3 ohms, sir.
3 ohms. So we're gonna get, how much are we gonna get there? 7.17. Did you get the same?
Yes, sir.
Then what is the units of voltage?
It's V, sir.
V, volts, yes.
Yes.
Perfect. Okay. There's another method you can use. The other method you can use is to use ratios. You can use ratios. So using ratios, you know that V at 3 ohms will be given by, let me see something. It will be given by the resistance that you are looking for divided, let's say if it's R1, divided by R1 plus R2. You can use it. This is just my formula. It works fast. It can work faster. So it's 3 divided by 3 sorry. It has to be R1 divided by R1 plus R2 times the total voltage. You can get the same. So it's going to be R1, which is 3 ohms, is this R1 will be 3 plus the resistor of the other branch. It was I think it was 7.9. 7.9, right?
Yes, sir.
Then multiply by 26. So what is it that you got there? I just want to see. Maybe to get the same answer. You get the same answer.
Good checking, sir. I got 7,16.
You got 7,16
Yes, sir.
V. So it's almost similar. It's almost similar. So I used to use these formulas back in the days when I used to create my own shortcuts. Yeah, so I used to use ratios a lot. I would tell myself that, okay, we have the total voltage of the circuit, and that total voltage is going to be shared across the resistors in series. So to see how much share will 3 ohm resistor get, then I will say the 3 ohm resistor divided by the total resistance of the circuit, then times the total voltage to give me the portion that is going to 3 ohms. Do you see where I go to that answer?
Yes, sir.
Okay. Let's see the next question. The next question says, a battery was then replaced with a battery of an unknown voltage and a charge of 12 coulombs flows through the battery in 5 seconds. They said, calculate the current that passes through the battery. How do we go about that one?
Ooh.
Kumisa?
Yes, sir.
What? Okay. What is the definition of current?
The flow of charges inside a conductor over a specific time.
Let's put it into a formula. Okay, current equals what you just said can be put into a formula.
Oh, it's current over Q.
No, but you said
equals
current equals the flow of charge, which is what? It's Q divided by
the change of time.
Change of time. Then you're done. We are looking for what? We are looking for current. Do we have Q? Do we have Q?
Yes, sir.
Do we have change in T?
Yes, sir.
Then we're done. So how do we calculate I then? So let me set it up. It's 2.2.5.1. 2.2.5.1. So I'm going to have I equals Q over change in T, which is, our Q is what?
12 coulombs.
12 coulombs divided by time. You agree?
Yes, sir.
So it's going to be, the answer will be 2.4. What is the units of current?
Net amps, sir.
Amperes. Perfect. Okay. Let's go to another question. Calculate the current that has passed through, that passes through 23 ohms and 12 ohms. Now that we have a total flow, that flow is going to split. You agree?
Yes, sir.
And then it will go into two branches. Now they want us to calculate the current that is passing through 23 ohms and 12 ohms. So how do we go about it?
Are we going to use the formula RT is equals to R1 plus R2?
Yes, I agree with you. To solve, you said RT equals
R1
or
plus
one of
R2.
or 1 over RT.
No, sir.
Okay, you said RT equals
R1 plus R2.
R1 plus R2. Then what are we trying to solve? The total resistance. Okay, we do have the total current, right? You agree?
Yes, sir.
Okay, so if we have the total current, do we have the total resistance?
Yes, sir.
It is going to be R1 will be
10,9.
it will be 10. Everything will be 10.9. I agree with you. I agree with you on that one. We're on the same page, right?
Yes, sir.
Then from there, we do have the total resistance. Then what? Then what? So what will be the second step now? I said that everything revolves around Ohm's law. Everything in the circuits revolves around Ohm's law. Do we have our total resistance? I think we do. In this case, do we have voltage?
Yes, sir.
Do we know the voltage across the battery?
Yes, sir.
No, we don't, because the battery was replaced.
Oh,
So you must mark these keywords. So, but do we have the current?
current, yes, sir.
Then if we have the current, it means automatically we will have V. You see where they are tricking you?
Yes, sir.
Okay. So I'm sure you agree with that. And then what is our I?
2,4 amps.
2,4 times the total resistance 10.9. So it's gonna be how much? Let's see. It's gonna be
26,16.
okay. 6,16
No,
26
26,16. Yes, sir.
26
16.
116. Okay. So that is the total voltage across the battery. You agree?
Yes, sir.
Okay. So if we have the total voltage, how much voltage do we have across across our equivalent resistance, or across our parallel connection? How much resistance, how much voltage do we have? Now that we have calculated the total voltage, that total voltage will be distributed into different resistors, into the resistors in your circuit. So in this case, how do we calculate the voltage across the parallel system?
Mhm. Isn't the formula gonna be V over RT is equals to V over R1 plus V over R2?
You said V equals
It's V over RT
V over RT,
is equals to V over R1
V over R1,
plus V over R2.
V over R2. What you're saying is right, but remember, we're not gonna use that formula. I was just using this formula just to demonstrate how we got to 1 over RT. Because I said, if you're dealing with parallel connection, your voltage across all the resistors is the same. So if that's V total, they will all cancel. You will have 1 over RT equals 1 over R1 plus 1 over R2. So as a belief, from now onwards, don't even think about this formula. I was just using it to show how we got to the formula of 1 over R. Because what I was doing there was I was just adding the I's, because V over R is actually a current. You agree?
Yes, sir.
Yeah. So I have said to you that throughout electricity, we're going to be using Ohm's law. Most of the things we are doing is Ohm's law and the sum of resistance. Ohm's law sum of resistance. Ohm's law, sum of the resistance and the total current. So in this case, do you agree that we have the equivalent resistance of 7.9 across the parallel connection or the parallel system? You agree?
Yes, sir.
So according to Ohm's law, V equals what?
It's gonna be V is equals to I times resistance.
Okay. Now, what will be the resistance across the equivalent resistor? It will be
Isn't it gonna be 26,16?
that's voltage, not current. You agree?
Yes, sir.
Okay. So your resistance will be the total resistance 7.9. So this will be, let's see, 2.4 times 7.9. It will be 18.76 volts. That will be across the parallel system. So if you remember from the notes, we know that the potential difference across the parallel branches of a parallel system is the same. Do you agree?
Yes, sir.
So this will be, so they are looking for us to calculate the current that passes through 23 and 12. So what is the formula of current? Ohm's law. It will be
I is equals to voltage divided by resistance.
okay. Now, this will be, what will be the voltage at 23 ohms? (18.76) divided by the resistance will be 23. Do you agree?
Yes, sir.
This will give us a current of 0. It's actually 0.82. 0.82 amperes. And then what will be the I at 12 ohms? How much will it be? I remember we had 24 of a flow flowing, let's say if that's water, 2.4 amperes of water flowing in a pipe, and then one branch took 0.82 ampere flow of current. What will be the remainder of the other branch? What will it be?
So we're gonna divide 0.82 with 12.
We can do that as well. 18.76 divided by 12. That's another way. That's okay. So how much are you gonna get?
One comma 563 recurring.
1,563 amperes. But look, if you have 2.4 A's of current flowing, and then the one branch takes 0.82, it means the other one will take 2.4 minus what is in the other branch. You agree?
Yes, sir.
Okay, so what do we get? Can you use your calculator? Let's see if we are correct.
Zero comma 158.
It's the same. It's the same, wasn't it?
It's 1.58, sir. Sorry.
58.
Yes, sir.
Yeah, I mean, it's almost the same. You can do this. You will get your marks if you do that also. So back in the days when I was in grade 10, this is what I would do. I used to use a lot of ratios. I would just say, okay, sharp. I within 23 is given by the R within the within 12 over R 12 plus R 23. Then multiply by the total current, which is 24. So let's see if we're gonna get, so I at 23 will be 12 divided by 23 plus 12 multiplied by 2.4. Let's see what we're gonna get. You can use your calculator. Let's see if I'm doing the right thing or not.
It says here 0.8228.
0.82 is the same thing.
Oh, yeah.
Yeah, it's the same thing. I used to use these shortcuts and they work. So for 12, I'll just say R23 all over R12 plus R23. So my shortcut times I total. You'll get the same. I think it will be 1.5 something. You'll get the same thing. So there's so many ways to skin a cat. So let's go to the next question, 2.2.5.3. It says, calculate the potential difference across the new battery. I think we have already calculated it. You agree?
Yes, sir.
So it's actually 26 point. You know how to calculate it. You have done it. It was 26 point what 0.16. We have already calculated it. So it's gonna be 25, 20, no 2.2.5.3. So V total equals I total R, which is 2.4 times 10.9. So it gave us 26 point, you said 0.16, right?
Yes, sir.
Yeah. Okay. Now, the last question says, if a longer filament of 3 ohm resistor was lengthened, what will happen to the resistance? Will it increase, decrease, or stay the same? What will happen to the resistance if we increase the filament? Let's say if a 3 ohms was a light bulb and it has a filament of a certain length, then we decided to increase the length. What will happen to our resistance? Increase or decrease?
I think it will decrease, sir.
Why will it decrease? Why will it decrease? Oh, okay, let me put it in this way. I gave you a very nice example. I said in life, if you are successful in life, you will have resistance. That's normal. Whenever there's flow, if you are flowing in life, you will get resistance. Let's say if your journey is too long, if your journey is too long and within that journey you are getting a lot of opposition, at the end when you sum up all the opposition compared to when the journey is short, will you have more opposition in total or less if the journey is longer?
I think you have less opposition.
If the journey is longer,
Oh, yeah, more, sir.
you will have more. You will have more because the journey is now longer. The same thing with charges. If you lengthen the filament, the charges will take longer to travel and encounter more resistance along the way. So the resistance will increase.
Yes, sir.
Why? Because there will be a longer path to travel. So what happens if I increase the diameter of the filament? Will the resistance increase or decrease?
Please repeat, sir.
If I increase the diameter of the filament inside the resistor, what will happen to the resistance?
Oh.
What will happen? Let's say, for instance, if you have a pipe, and you increase the diameter of that pipe, will the flow be easy or will it be hard? Or if you are going inside a hole and then the architect decide to increase the size of the door, will it be hard or easy to go in?
It's easy, sir.
It's gonna be?
I think it's going to be easy.
it's gonna be easy. Meaning, if you are using resistance term, meaning
It's going to be shorter.
no, your resistance, will it increase or decrease? The opposition.
Or it decrease.
It will decrease, definitely. That's what I'm saying. The opposition will decrease. It will be easy to enter. It will be easy to enter. So I think we are done with our lesson, and we're also done with our task. So from now onwards, I want you to go and collect whatever question you think was tough for you to do. Do it. If you encounter a problem, then you DM me with that problem with the solutions. I will do that problem with you guys in the class.
Yes, sir.
Yeah, so from there onwards, we're just going to be doing problems. Just going to be doing problems. Yeah, and
Yes, sir.
and which chapter are you guys doing right now?
We're still on longitudinal waves, sir.
Longitudinal waves. And how are you finding it?
I understand it, sir.
Okay, is it similar to what I was teaching?
Yes, sir.
Oh, okay, yeah. Yeah, so just go there and dominate, because already you are ahead of the syllabus. You're already of the syllabus. You are already ahead of the syllabus, so you can do whatever question you can do in term 1. Challenge yourself, because at the end of the day, that's what you're going to be writing on. Then if you encounter problems, I'm always here. Then you just send the questions. Then at the end, before you guys write your test for term 1, we're gonna have a test also, so that I see where you guys are.
Yes, sir.
Okay, now I will see you next week, Tuesday, 5 o'clock.
Yes, sir. Bye.
All right, enjoy. Sure.